So let's look at an example of earlier you have looked at example of confidence interval when your sigma is known. So let's look at this example here when your sigma is unknown. All right, and remember, when your sigma is unknown, you actually use t distribution, right? So see that this is actually extracted from a lecture slide. The weight of an object is measured 8 times using a scale that reports the true weight plus a random error with zero mean and unknown variance. So you see that it's actually indicated that it's unknown variance. So when we don't know the variance, it also means that we do not know the standard deviation, right? So assume that the errors in the observations are independent, and they actually give you some data here. So you actually have 8 data of it, and then what they give you is that the x bar is 0.5747, and then they actually give you this data also, and you can see that it's actually s square given by 2.636 times 10 to the power of negative 3. All right, so which means this actually is my s square, which is my variance. All right, and for you to get your s later, you just basically get the square root of it. And what do they want us to get? They want us to get 95% confidence interval for the mean. All right, so if you remember earlier, what do we do about it for the confidence interval? Confidence interval is just your x minus x bar minus your t of your s over square root of n, and then your x bar plus t of s over square root of n. All right, again, then it means that you actually need to find if I just draw this out. All right, so I'm talking about 95% confidence interval, which means I still need to find my LCL, my UCL here, and this actually gives me again 2.5%, which translates into 0.025. All right, so in this case now you want to find the probability. All right, if you look at your t table, and then you will see that the probability where your t is your probability at 0.025. all right, and let's look at the table, and it will actually sort of give you 2.365. all right, so not that the way for you to find the t is exactly as what you find for z value, only there is actually different table. And you can see that now this is unknown standard deviation, and this is literally just 8 samples that we have here. Okay, and then we do know what are the other data that we actually get. They already give you the x bar. The x bar is actually 0.5747. all right, minus my t is 2.365. all right, and then I'll multiply by 2.636 times 10 to the power of negative 3, right? Divide by square root of 8. Yeah, because this is actually, and do I miss out anything here? Note that this value that they give us is actually a variance, so therefore I need to take a square root to get the s. Okay, this is for the lower limit, and of course for the upper limit I'll just repeat the whole step. I'll just put a comma here, so I'll just have this as well, plus 2.365 multiplied by square root of my variance, which is 2.636 times 10 power of negative 3 over square root of 8. Yeah, so, and this will give me the value of 0.531 and 0.618. all right, so as you can see, it's basically just the same thing, only that you're referring it from the different table. all right, so in the videos we have actually covered the concept of CI, the confidence interval, and the most important formula, right, when your sigma is known, you just basically use the Z table. And when sigma is unknown, then you use the T distribution. All right. And do remember that it is actually just the same formula. Even when sigma is known, we just replace this T with Z. All right. And this, of course, with the sigma. All right. So I hope you're very clear with this, because in fact, we're going to use this, and this information will be important for our next topic later in significance testing. Okay.